So my name is Steve Dalton. I'm the Senior Vice President of Product Strategy and Technology. I'm very happy you guys are here, and I'm excited. It's been a while. Actually, I don't know if we've ever met with the analysts in the level of depth that we're going to have today. And we got the engineering team here that is laid out in green. I'm not going to introduce each one of them. You guys introduce yourselves when you come up here, since there's quite a bit of you. But we're awful excited here. We're awful excited at Violin on what we have and what we have to offer. And again, I want to set the foundation for what we have, and from a higher level. I'll touch into a little bit of the foundation on the architecture and the technology, and then we're going to walk through every component and every level of the architecture over the next 2 hours. So hopefully at the end of the day, you're very familiar with the Violin technology, the Violin direction, and what we're up to here at this company. Again, we're extremely excited that you're here. We're very happy about what's going on, and I'd like to take you through that now. So just to safe harbor, so Violin, and again, I'm just going to give an opening here. So we have a very active company. Despite what people may hear or view as, the company is in good shape. Kevin came on a little over, almost 2 years ago now, and I've been here for almost 3 years, and the team itself, many of them have been here before me. So you got a very seasoned engineering team that has developed one of the biggest technology disruptors in the industry for many years, and really the level of this was to take the technology from expansion from the server side into the SAN to basically address the issues that you have to address with flash technology. Okay. The company itself has done quite well in terms of deployment. You can actually see the different logos on the different verticals. I won't walk through each one. You can actually read them for yourself. We do have Fortune 500s across there, and we do have ongoing logos that we're bringing to the company on a regular basis. So as you can see, we are mainly in the enterprise, but we're really focusing in on the expansion of what we're going to be doing here in the primary storage space for flash technology. The business technology itself, again, Kevin went over the financial stability. I heard that going on there, so I won't touch on that. But it is a proven technology, a proven company, and we're in the despite again what people may think, we're basically in the discussion on every single one of the deployments that are out there today in the enterprise that are going on today, and we'll walk through that. Over the last 2 years, we have built a very, very different architecture, okay, from what Violin basically pioneered the technology on. It originally pioneered on a tier 2 performance-driven technology. Over the last 2 years, and I'll walk through that a little bit, we have evolutionized where the company has gone in terms of how we're going to address the evolving platform at all-flash array. And really what we've done is built a complete operating system that's going to address the entire data center for where flash is going. So, how many here really view the TAM of the markets in different ways? I'm sure you guys. Howard, you're pretty familiar with this. What's your overall view of the all-flash array TAM today?
I don't think in dollars.
Okay.
So, but AFAs on a dollar basis are probably 10 or 15% of the total storage market today, and should be gaining 3 to 5% of market share a year.
Okay.
To stabilize at about 50%.
Right. Anybody else?
I have something to say on this.
Sure.
Sorry, I'm not sitting at the table, but I did get a mic. Yeah, this is one of those things that I've seen a lot where people talk about the all-flash array market. But personally, I feel like the entire primary storage market is potentially a addressable market for all-flash arrays. So I've had this argument again and again with some companies who like to claim that they dominate the all-flash array market, only to find that the all-flash array market has magically grown by 100 or 200% in the next quarter, because frankly there is no such thing as an all-flash array market. There's a storage market, and these arrays are absolutely potential addressing that whole market if they do what you need to do and they're fast and affordable.
Yeah, right.
It's the all-flash array market is the whole storage market.
If it's tier 1 storage, you're not competing. You're not competing with Pure. You're competing with EMC and HDS
everyone
on across
Right.
everything.
So,
Thank you.
Thank you very much, Stephen. So here's how it is. So when I first came here, again, close to 3 years ago, again, I was a GM of Flash over at Intel prior to here. And the big evolution of Flash evolutionized from the server side, as everyone knows. Then it creeped itself out because the server side can only scale for so long. And as Howard was saying, the compute and the scaling, the memory can only scale for so long. So in came the storage array technology for capacity expansion that allowed Flash to basically come into the footprint of actual a storage array. Many people doubted that at the time, but that was really the evolutionary beginning of Flash in terms of storage array technology. This market here basically is what we call tier 0. Everyone knows this. And you can see where the market TAM is. And I got a lot of research, and I'm happy to email it to you after this session today. But what it is that this is known as the IO intensive market. And the way that we have it today is 70%. The whole market in itself is about 2.44. And about 70% is the penetration of all flash array that's addressable with that type of technology. This is built upon fast performance, high IOPS, and low latency. If you do not have that type of technology, then that's a technology that's probably not going to be suitable for that tier, okay? So as you can see though, the TAM in itself is smaller compared to the other segments that have now grown over the last 2 years. So as Violin evolved the tier 0 technology, we have understood ourselves, and let me tell you, it's not easy, it's a not easy formula to understand what you're trying to do out there on the other tiers. We always talk about primary storage. The primary storage addressable market, and some people will say this is higher. I put an aggregate number of 20 billion, and I got anywhere between 15 to 30 billion in terms of the numbers, but it's about 20 billion. This is a smaller for all flash array, this penetration rate is a lot smaller today. It's 25%, which leaves a TAM of about 7.42, which puts this really in the primary tier evolution. This is also very tricky because what you're trying to do there is replace what has been there for 20, 30 years in terms of all disk technology or even tape technology to this day that has evolved, and that same evolution has to take place. So that's actually a very big challenge for the all-flash array companies to do that.
So Steve,
but that's something that we'll be
there's been some
targeting.
discussions in the market that flash shipments represents anywhere from 5 to 15% of all the data bits being sold in a year. How do you attribute? So the market penetration seems to imply it's higher than that from at least a revenue perspective. Is it because of the high cost of flash? Is that?
In terms of it seems to be higher than this.
Well, so
higher,
if it's
higher than the 10 to 15% that you said. Yeah.
5 to 10,
Well, let me
15.
tell you right now. I'm sorry, your name?
Right.
That's Ray.
Ray. I'm sorry, Ray. Thanks, Ray. So, Ray, I'm going to be realistically what we have learned. Now, we've learned a lot with this company over the last 2 years. Okay, as it's transition, as Kevin was talking about, the transition that we have gone from the tier 0, which we know very, very well, into the primary storage, and then what we'll call actually the lower end of the primary storage, which is really the data reduced and the VDI space. What we have learned is that to penetrate in the primary tier, it's just not having the data services. It's just not having the software. It's just not having this. You got to have all the elements that can actually build a replacement for what has worked for 20 years already today. So to walk in there and say that it's just going to be performance or it's just going to be an IOPS play or latency, that's good. But you have to have a lot more understanding of what that is. That particular thing is being learned in the data center by the IT folks and the CIO folks. So that's where you might get your 10 to 20 or 15%. However, from our learnings, in our deployments of our new product line that I'm going to go over here, it's well over actually 25% in terms of what's available, in terms of what we can actually achieve. But the actual deployments today are more likely in that 10 to 15% because the data centers are still learning how to build an all-flash data center with primary storage.
So
this is the actual addressable market because we have the data that actually shows we have well over actually 25%. I'm giving a little conservative here on what the primary storage opportunities are today.
To more directly answer your question, the 17% of all bits sold into enterprise storage includes all of this flash in hybrids.
Yeah.
And he's just talking AFA.
Yeah, and what is achievable, and again, what you take into account is we're not ready to move to all flash. We're not ready to do this yet, so that's your other 75%. So this is where that's addressable.
And I look at tier 0. I see that as like PCIe flash in the server. You're saying it's really storage.
So tier 0, so that's a great question again, right? So this is one of the big things I did when I came on board. Tier 0 is, when you really look at it, you can actually have it in tier above. So look at the hierarchy of compute. Hierarchy is you got compute, okay? You got memory, which is DRAM. Okay, now you're going to come into flash, which is now why was flash evolutionized in the original days of Intel, 10, 11 years ago? The original answer was because it wanted to eliminate DRAM. That's why. So if you eliminate DRAM, then the cost is going to really, really be advantageous to how they build the server side capabilities for memory use cases. Okay. Now, as that went over time, what they wanted to do is make it persistent. They wanted to build the capability to store data on the flash itself, so they can actually run closer to the applications, which would eliminate the latencies of the network and the latencies of the actual array, the back and forth, okay? And if you're able to put the storage on the server to the application, which is really where your working set operates, your working set from the application sits on memory, and that's really what evokes your application workload. That is what Intel solved with building the server-side flash. That is what you consider tier 0. Tier 0 would be the memory to flash stickiness between those two. So that is, yes, that's exactly tier 0. What we have done...
You're way too into the engineering definition.
Well, okay.
Tier zero by the very name indicates that it's abnormal, because we start counting for normal people, not engineers, at 1. And so tier 0 is anything faster than normal.
Okay.
So I go back to the time when tier 0 meant it had protract disks. Mm-hmm. It was like any tier 0 are the applications that a small number of people are willing to pay a large amount of money to make go faster. It's the hot rods, the dragsters, the jet-powered cars, and flash is now the new normal in tier 1.
Yeah, you're right, Howard. Yeah, I wanted to give a little bit more of a technical thing, being the audience, but my if I'm looking at it, if you looked at it from the way that the hierarchy works, that's really how they view it. Now, that being said, tier 0, to Howard's point, is the capabilities to keep that performance and IOPS closer to the server, okay? So for that case, you want to have the type of latencies and performance that can mirror what the server side is doing to add that capability, as Howard said, to the high level of performance. So that was the original TAM. So that's the original market. And so Violin, 2-3 years ago, basically dominated that market. And over time, that market shifted, because what happened is the server side basically got more captive, and the capabilities to expand that type of performance into the data center became more relevant. Okay, so now you wanted to build more cost enablers for for the TCO, and be able to build the types of solutions that would actually keep those applications being able to run at the speeds they can. But as they scale, you needed to have a flash platform to do that. Thus, the evolution of the next generation of flash tier. So where that came is that they had to focus on those use cases that made flash cheaper, because now the big issue of cost came in. Cost was very expensive. Without getting costs down, you couldn't get flash to basically replace disk. Thus, the data reduction in the VDI space that evolved deduplication for flash. And this is what other companies have now done over the last several years, and that's been their big. But that's been their big play here, and that's what this is here. This TAM here is really based upon cost and capacity, and this is what you see other companies do with deduplication, which is about a 60% penetration today. The overall TAM being 10.6, leaving that with 6.6 for this space here. And then lastly, like I said, the penetration 25 to 20 puts the overall TAM market for all flash arrays that we have calculated that we can go address is about 15.78. Now, the reason I'm talking to this is it's really important for the next slide, because what we have done here is we built a platform. So taking this into consideration, we studied the market really well. And we just didn't want to take software, throw it onto a box, and say we have data services, okay? That's easy to do. Off-the-shelf type of technology that can go build something that can that can say you have an all-flash array. We had to study the workloads. We had to study what the pain points were. We had to talk to many IT directors and many CIOs to understand what the technology was that we need to deliver to actually solve their problems for the entire TAM. So we built a platform called the Flash Storage Platform that we call 1 equals 3. One platform covers all 3 of those segments. So how did we do that? We evolutionized our initial product, which was the 6000 series. Okay, the 6000 series was a product here that built Violin. And this was built on a software called VMOS 5, which was Violin developed software, and another software, VMOS 6, which was a co-partnership with Symantec. So yeah, that's public, and you've heard all that. And this was over the course of those years, this was the TAM that Violin was addressing, okay? So you can see from what people may say about the company, we are performance only and we're addressing a small segment of the market. However, over the last 2 years, we've taken our technology here, and we got people here, and Jeff Cuppett and Chris Zhang, that will talk about our next generation 4 FFC controller that some people will call CFM. And this is a customized controller, ground up, built from 9 years of IP now that we have evolutionized now into our 4th generation. This is what enables us to be close to that tier 0 steel and be the leader in that space, because without that, we couldn't get the type of performance and the type of characterization that we need to do to solve the use cases that tier 0 needs. So we continued that investment, and we built that. And then over the course of the last 2 years as well, we built this Concerto OS. The Concerto OS was leverageable between our own design, VMOS 5, acquired IP, and our embedded software designed from 8 years plus. So it's a combination of 3 elements of software that we recoded, intertwined, interlocked, and re-architected for the last 2.5 years, basically. This is the platform that was able to build this, okay? So enabling to build this, we have built what we call the Flash Storage Platform based on the 7300. The 7300 has 3 distinct segments that we actually productize, okay? The first one, performance, is going to be performance only, performance driven. That means it's going to be no dedupe. Thick, thin, you'll have async replication, you'll have snapshots, you'll have clones, and you'll have other elements that you can so use. But at the end of the day, we have built this and optimized it specifically for this performance tier, because we feel we can still continue to evolutionize that, because as that still carries on in the marketplace, we will want to be the leaders there still. We don't want to give that up, and we won't give it up with that type of performance and the type of technology that we have. And we're going to go through every area of this today, and we're pretty proud of this. So this is our hardware that's allowed us to build the type of technology to be the leader in that space. On top of this, we have the enterprise product, the 7300 Enterprise, 17 terabytes to 70 to start. This can also use the 7700 that we have our 2 external controllers that we add for scalability that allow us to scale up to over 2 petabytes, okay, and several million IOPS. Okay, and we'll walk through all the data. We'll show you the numbers, and we'll show the thing. The thing that I want to bring up is sustained, because sustained is always the big number in Flash, as everyone knows, right? And I don't need to explain that.
So you run the data services layer on the little controllers in the 7300 until we need to scale up?
That's right. So it's on the 2 controllers as they run on the 2 MGs here that you see the green ones there.
Yeah, and the ones you tried to run memory. You tried to run Windows on, but there wasn't enough memory to make it work.
The other 2 controllers.
It's a good product.
And
so we are. And what we're doing there, Howard, is we're completely TikToked with Intel. So we're currently going to Haswell, then to Broadwell, and as everyone knows. And well, I'll get into it in a little bit of detail. I was going to talk about the memory sizes for deduplication, and I want to walk through that. But let me finish this part first. So here's where we also said, okay, so here's the thing. For the last, Kevin, when did we launch it? March? February. So we launched this product in February. And the launch of a new platform like this is a huge launch. It's a heavy transition. What we did is we learned a lot. We just didn't come out and want to say, hey man, we got a new product and we're bragging about this and that. What we wanted to do is work with the customers, work with the field, and work with everybody to understand what we need to do further to really make this the right portfolio for the segments we're going into. So when we studied all that and did that, we came back and said, look, we can't do one thing does all. We could, but if we're going to do it right for people that want a performance product, we need to develop a product specifically that fits that needs. Now, for people that want disaster recovery and they want to build a primary storage data center, that is our FSP Enterprise. So this has all the data services, again, recoded, redesigned, specifically with our hardware, built with our new management software that we'll walk over with Gamunder, that has completely addressed what is necessary to replace disk in the data center. So everything that we'll walk through there, from how we do async replication, synchronous replication, the cloning, the snapshots, stretch metro, all flash stretch metro, one site to another site. These are all the capabilities that we have internally within the enterprise. This is mission critical. So this is the issue, Ray. Looking back at you since you asked the original question, going from the tier 0, which is not mission critical, even though I know people are there's tracks to do that, to the enterprise is not that easy in all flash. So doing this, we really feel that we have addressed the market the right way to really be a true player in the enterprise.
So the 7300 has dual control units in it?
That's right. It's right here, and we'll walk you through that. And then lastly, the capacity. So what we also learned is this: we have thick, thin, and dedupe runs. We're flexible. We can set up our designs to run any type of workloads and mix workloads simultaneously. So we could run a dedupe operation and performance operation in parallel. Okay, that's what we can do. Okay, that's what we'll do like in the enterprise. However, in this area, well, really they don't care about a lot of that. They only want cost per gigabyte, and that's it. Then we have optimized our code base to do just that and be the best deduplication capability out there in the industry. Okay, so this is built specifically for cost and capacity. And again, this won't have thick, thin, but it will have async rep and snaps and clones. And this is where we get our capacity up. This 200 terabyte footprint is memory based. So as we double our memory, this will double the capacity in a single array. Okay, when we go to our next generation processor, which is Haswell, and our 2 terabyte VIM. Okay, so this is, any one of these can move to a scalable product if you need to. And this is how the entire portfolio that we have now launched over the last 6 months that has now been in a transition for the company Violin. So hopefully now people understand how we can now address all the 3 segments of the TAM in the all flash array market with one platform. So
and the interface is Fiber Channel or iSCSI?
Fiber Channel, iSCSI, InfiniBand, and we are doing some other things that we'll walk into, like the RDMA. Rocky, which we actually do support, but we support as needed, in those. Okay, as I'm onto my last slide here, I wanted to just give one last summary of the technology before we go into the deep dive. So hardware up from here, you got the hardware here, which is our own flash controller, which we call the Violin in-memory module, which is right over here, and we can pass those around or walk over there through this session. We have our four-way HA RAID controller, which is what we call our VCM. This is a custom designed RAID controller specifically built and optimized for flash at the hardware level. So our latencies and our performance off our RAID engine is extremely fast. That's a very patented technology that we have had for quite some time. And then our purpose-built Intel servers. So with this, we walk into our data services, which is our Concerto. And so the different layers that we have here in terms of how we do our learning, our data services here with snap replication, and then our protocol interfaces out into the SAN, our HA and management services here, along with our REST API that interfaces with our Symphony software, which is a single pane of glass that has been, is one of the, we feel it's one of the, we don't call it simplistic or things like that, but it's very simple. A few clicks, we'll give you a demo on this, on how we run the data center through a single pane of glass. This is also has an object layer that supports the private clouds. So we can support today OpenStack as well as other cloud software out there that do that through our REST API infrastructure that we have. Okay, so hopefully that gave you a good round summary of the technology to start. And now I'm going to turn it over to Vikas Ratna.
Can I ask you a question before?
Yeah.
As you move more into primary storage and away from just pure performance, it's obviously going to be a more crowded space of vendors. Where do you guys start as far as pricing and things like that go?
For the primary storage?
Yeah.
So it's a great question. Primary storage is separated a little bit. So at the low end of the primary storage, we're going to be sub $1 a gigabyte. Okay, at the low
Is
end.
that raw or effective?
That's effective.
Okay.
And that's a big thing between the two. Okay, effective and raw. That's what you're going to get. Okay, so and also not usable. I'm talking about effective now. So then that's actually why we segmented the products the way we did. So at that low end of the tier 1, we come in below $1 a gigabyte, and then it depending on the software and what you're building out there, it can range. But we want to be very aggressive in that area. Yeah.
You said that you can scale the product that you already have, functional next generation memory that will be in the system. So does it mean that the Vim module is the only thing that you have to manage to change to get this capacity bump, or do you need to do something more complicated in the overall architecture?
So the Vim module itself doesn't need to change when we scale. The thing that will allow us to scale, we can scale today with our current, it's compute memory that allows you to scale, and the software. And so we have the software that dynamically expands. It's one expansion and scalable. So, but it's the compute memory off the MGs that allow us to actually scale. And so that's why we're on a very fast, TikTok again with the Intel and the processor, because we can scale to 10 systems today under two controllers, but you're going to be limited on performance, obviously, because you can only go so fast under that load. But once we up so the VIMs itself, nothing else changes. So the VIMs itself and the VCM, the RAID controller. We also have another board in there called the ACM, which is our array controller technology that monitors the system. That all stays put. So now, if we go to new bus interlinks like PCI NVMe Gen 3, things like that, which we can talk about today, then you got some changes there. But we don't want to do any hardware changes to anything when we scale. It's all based upon the memory and the compute, which is a pretty straightforward thing for us.
And some of those things will be covered as we go through under the hood, taking a look at the various components, what changes where, so we'll cover that.